Let us solve this by using the forward substitution method. We know that T1 is 1. Oh, there we go. T1 is 1. T2 is, according to this formula, is T1 plus 2, which is 3. T3 is T2 plus 3, which is 3 plus 3, which is 6. T4 is T3 plus 4, which is 6 plus 4, which is 10. T5 is T4 plus 5, which is 10 plus 5, which is 15. That's actually enough forward because we can see a pattern. 1, 3, 6, 10, 15. 1, 3, 6, 10, 15. This is a second difference. It's a quadratic sequence. The difference here is 2. The difference here is 3. Difference here is 4. Difference here is 5. And the difference here is 1. And the difference here is 1. And the difference here is 1. So the second difference is 1. And in the formula for the quadratic sequence, that means the coefficient is a half. It's half the second difference always. Now, if I subtract from these a half n squared, let's see what I get. So 1 minus a half times 1 squared. So that one is a half. And then 3 minus a half times 2 squared. That's 1. And then 6 minus a half times 3 squared. That's 3 over 2. And then repeating this one here will is 2. And then this will be 2.5. So it's a linear. So that's plus a half n. It's a linear, it's a arithmetic progression with a difference of a half. So that's the coefficient there. And we have to make sure it matches up with the first term, which is 1. That gives us the constant at the end here. When n is 1, we have a half plus a half, which is 1. So the constant at the end here is 0. So we have our formula Tn is n. I guess I could simplify it over 2 and n plus 1. A half comes out n plus 1. Yeah. Let's check the answer here. So using this formula, I will get 1, 3, 6, 10, 15, 21, 28, 36, etc. Yeah, so that matches up then. So there you go. That's the answer there using the forward substitution method.